Dear students, this is 7th video about metallurgy. Our topic is acid leaching process. Before discussing in this topic, just remember in our textbook have example of about leaching processes. Here the first topic, cyanide leaching. Cyanide leaching process, it may be applicable if we have gold ore or silver ore. And ammonia leaching process. In this process is applicable for nickel ore, copper and cobalt ores. And also alkali leaching. In this process it may be applicable if we have ore of aluminium bauxite. All the topics all are already discussed. Now our topic is acid leaching processes. What is acid leaching process? Already I told you, leaching process, it may be 4 types. Here acid leaching, it is one of the final and the last topic. In this acid leaching process, it is applicable for sulfide ores. Already I told you, galena ore and zinc blend ore all are a sulfide ore. Those ores all are very light weighted and hence such ores concentrated by froth flotation process. If we have extra pure of ore, now we are introducing acid leaching. What is acid leaching? Acid leaching process, it is nothing but whenever acid is mixed into a sulfide ore, here the sulfide ore, it is insoluble character. Such an insoluble sulfide ore, it is converted into soluble substance by using acid. Just you see here, the leaching of a insoluble sulfide ore, zinc blend, galena, it can be done by treating with hot aqueous sulfuric acid to convert soluble sulfate and elemental sulfur. So few sentence is here. Instead of the sentence, just you write the reaction also. So acid leaching, it is nothing but insoluble sulfide ore, it is become a soluble sulfate substances, and the unwanted sulfur, it may be removed in the form of a element. Okay, so this is called as a acid leaching process. The next topic, here the topic is extraction of a crude metal from concentrated ore. Before in this topic, just you recall, this is a second step of a metallurgical process. Initial step, preliminary step is concentration of ore. It is all are discussed. Now we are entering the second step of a metallurgical process. The step, it is extraction. Okay, so the topic, extraction of crude metal. I mean, end of the extraction process we have a crude metal. Crude metal, it means impure metal. So the impure metal, it may be get it from a concentrated ore. That's why extraction of a crude metal from concentrated ore. Okay, so here it is, 2 steps is available. We have only a concentrated ore. Maybe the ore is belongs to sulfide ore, carbonate ore, hydrated carbonate ore and halides ore, like that. So we have concentrated ore. in this concentrated ore, it is involved into two steps to convert it into crude metal. Here the first step is conversion of the ore into oxides. The second step is reduction of the metal oxide to elemental metal. I mean, any type of a concentrated ore is initially converted into ore of oxide. I mean, initially convert into ore into the oxide, metal oxide. We have a concentrated ore, isn't it? Lead sulfide, zinc sulfide, calcium carbonate, zinc carbonate. Those all are the concentrated ores. Any type of a ore we have, it is initially introduced into metal oxide. So the first step of the extraction process here, conversion of the ore into oxides. Okay, just you see. So after the conversion of metal oxide, involve reduction of a metal oxide to elemental metal. The second method, second step, it is here reduction of the metal oxide to get a elemental metal. Both the steps, it is very important. We are not able to skip any one of the steps from the extraction process. So here we are discussed one by one. Here the first step, conversion of the ore into oxide. Here, according to thermodynamic principle, I mean thermodynamic principle is here about the principle of thermodynamic. Any type of a metallic ore, it is not easily involved into a reaction. Any type of ore, it is not easily involved into a reduction of processes to get a crude metal. So the reduction of a metal, the reduction process, second step is reduction of a metal, isn't it? Reduction of a metal oxide to elemental metal. So the second step is reduction. That's why here the first step is introduced, the conversion of the ore into oxides. According to thermodynamic principles, the reduction of a metal oxide is easier when compared to reduction of other compounds of metal. I mean, the reduction process of lead sulfide, the reduction process of zinc sulfide, the reduction process of calcium carbonate, it is so complicated. That's why the lead sulfide, zinc sulfide, calcium carbonate and zinc carbonate all are initially converted into metal oxide. If we have metal oxide, the reduction process is very, very easy. That's why according to thermodynamic principles, the reduction of a metal oxide is easier when compared to reduction of other compounds of metal. Understand? So before reduction, the ore is first converted into oxide of metal. Are you clear? What is the necessary? The conversion of the ore into oxide. They are asking under board exam. Okay, just you read well. We are going to next slide. So here the first step, conversion of ore into oxide. Okay, I mean the extraction process, we have a two step. The first step is the concentrated ore is converted into oxide. Okay, so such a first step now we are going to discussing. Just you see here in this step, initially our concentrated ore is taken into a suitable furnace, blast furnace, reverberatory furnace, as like several types of furnace is available. In this selection of a furnace, it may be depend upon the ores. So here the first we are going to taking a concentrated ore into a suitable furnace and heated gently. That's why the process is called roasting. Roasting process is here nothing but a heating process, gentle heating process. We are all very well known, our concentrated ore, it is a solid substance. Each and every solid substance should have a melting point. Before the melting point of a solid substance, we are maintaining the temperature, isn't it? Now the process is called roasting. Okay, so roasting process, it is here before the melting point of the each and every concentrated ore. It is called roasting. Okay, so just you see the sentence. Applied for the conversion of sulfide ore into their oxides. I mean, in our textbook, sulfide ore and carbonate ore, hydrated carbonate ore, all are the examples. So initially we are going to taking a sulfide ore, I mean the concentrated sulfide ore. How the concentrated sulfide ore is converted into metal oxide. Such a process is here called roasting. Okay, so just you see, just we are going to taking a suitable furnace, taking a concentrated ore, sulfide concentrated ore into a suitable furnace, heated well. Just the process is done in the presence of oxygen. Okay, here main condition is maintaining the temperature below the melting point of the metal. So now the sulfide ore is converted into metal oxide. Just you see example. Galena. Galena ore is heated in the presence of oxygen. Here lead sulfide is converted into lead monoxide. Sulfur, it is converted into sulfur dioxide in the form of a gas. Similarly, zinc blende and copper glans all are converted. So it's a very very important roasting. Write note or explain the roasting process. They are asking under our board exam. Just you read well and you must write all the reactions. Don't select. Okay, so during the roasting process, what happened? Just we are maintaining the temperature about several hours. I mean 3 hours, 4 hours or 8 hours or 10 hours. Now what happened? During the processes, removes impurity such as AS. AS, it means arsenic. S, sulfur. P, phosphorus. Those all are the very very preliminary impurities. It is present in a sulfide ore. Such impurities all are converted into their volatile oxides. Okay, see the reaction. Arsenic, it is readily combined with oxygen to become arsenious oxide. It is removed in the form of a volatile oxides. I mean, it is removed in the form of a gas. Similarly, sulfur is converted into sulfur dioxide. Phosphorus is converted into phosphorus pentoxide. Just you see the formulas. I mean, sulfur suffix 8 is there, isn't it? We are all very well known. Atomicity of sulfur is 8. That's why this is called as a molecular sulfur. Already we know that. Or it may be obtained from the earth crust naturally. That's why the sulfur is present in the form of a molecular form. That's why S8 is here very necessary. Okay, don't write S. Similarly, phosphorus also. P4, atomicity of phosphorus is here 4. That's why P4. So our volatile oxides is here phosphorus pentoxide. In our board exam, they are asking during the roasting process, phosphorus, it is converted into dash. They are asking under in our board exam. Just to here the answer is phosphorus pentoxide. Are you clear? So here instead of P4O10, supposed to be we are writing P2O5. It is also a molecular formula for phosphorus pentoxide. So here note is there, isn't it? It is belongs to 2 mark. During the roasting process, the sulfur dioxide produced during the roasting process, it is very harmful to the environment. So in this sulfur dioxide, the evolving sulfur dioxide is there, isn't it? The evolving sulfur dioxide, it is trapped and converted into sulfuric acid to avoid air pollution. So in this note, it is very, very important just to read well. Our next topic is here calcination. It is a very definite question in our board exam. It is also a conversion of ore into oxide. Already I told you during the metallurgy process we are discussing second step of the metallurgical process, that is extraction. In the extraction process we are discussing the first step, how the concentrated ore is converted into oxide. Here already discussed the first topic is roasting. So now the second topic, it is also a concentrated ore is converted into oxide. In this process is called calcination. Okay, just you see the pneumatics concept. Concentrated ore, what type of ore is involved into calcination process? Our concentrated ore is belongs to carbonate or hydrated ore. Now the time only we are introducing calcination process. So the concentrated ore which is heated in the suitable furnace, but in the absence of air, it's a very important. In the presence of air, it is called as a roasting. In the absence of air, it is called as a calcination. During the heating process, in the absence of air, the carbonate ore is converted into metal oxide, and the unwanted impurities, it is all removed in the form of a volatile gaseous substances. Okay, so what happened during the process? What happened? The moistures are removed. We are all known our compound, our ore is already involved into a concentration process, have a moist ore, moist content. Such moistures are removed during the calcination process. Moistures are removed. Volatile impurities all are removed. Volatile impurities, it means easily evolving gaseous substances. Sulfur dioxide, isn't it? Sulfur dioxide as like arsenious oxide, phosphorus pentoxide, all are called as a volatile impurities, all are removed. Here also all are removed. Unwanted gases all are removed, and a solid ore is become porous. Already known, our ore we are get it from a earth crust. That's why our ore contain a small amount of organic impurity. Due to the reason, our concentrated ore, it may be have pores. Are you clear? So here in our textbook example, just you see, during calcination of a carbonate ore is converted into carbon dioxide is expelled. It's a very, very important line. Okay, so here examples. Lead carbonate, which is heated in the absence of air. It's a very important. Lead carbonate is heated in the absence of air. The lead carbonate, it is become a lead monoxide and carbon dioxide. Similarly, calcium carbonate already known, limestone. It is also under the calcination process. We have a calcium oxide and a carbon dioxide. And already I told you the ore of zinc is here calamine. So it is also involved into a calcination process to become a zinc monoxide. Zinc oxide is otherwise zinc oxide. Similarly, dolomite is converted into magnesium oxide and a calcium oxide. Here also, during the calcination process, it's a very, very important gas is evolved. Such a gas, it is called as a carbon dioxide. Are you clear? Okay. So during a calcination process, some hydrated ores also involve. Limonite, Fe2O3 and 3 moles of water. It is also involved into a calcination process in the absence of air. Here ferric oxide, it is converted into ferric oxide, and the water particles are removed in the form of a vapor. Just you see here also some alumina ore. Okay, here also we are taking alumina ore just to introduce into a calcination process. Here the water, it may be expelled in the form of a vapor, and pure alumina is obtained. Are you clear? So it is all belongs to calcination process. It's a very important. Read well. Thank you.